Good morning. Welcome again to ITC facilities in Pozo Izquierdo, those that are attending the conference physically and those attending remotely through streaming. Also, thank you for being there. And well, and again, apologize for the delay we had at the beginning of the conference. Well, today we will begin with a representative of the Spanish Ministry of Defense from the Research and the R&D Institution, the National Institute for Aerospace Technology, INTA, and we have a representative, Dr. Fernando Isorna. He's a chemical engineer from the University of Seville and a PhD from the University of Huelva, currently combining the work at INTA with the academic work at both University of Huelva and Loyola University in Seville, where he's teaching at the master's program. Well, he's responsible in INTA. He's the head of the Energy and Environment area. He has been active in many international hydrogen-related projects. And also, I mean, as we mentioned, he's teaching in the case of the University of Huelva in the degree of remotely piloted aircraft systems. In the case of Loyola, is participating in the Hydrogen, Energy, and Technology Masters. And well, Fernando, thank you for being here. It's a real honor. And please, the floor is yours. Okay.
Okay, ahora. Thank you very much. First of all, I would like to thank to ITC in general, in particular, Salvador, Santiago, Gonzalo, for your hospitality and for the wonderful and so nice conference that you have organized. Thank you very much. So I'm going to talk to you about the use of fuel cells for generations of energy in geographical isolated areas or in island, let's say. So I have prepared a presentation. First of all, I will give you some words about what INTA is. And later I will give also a short explanation about fuel cells. I know that most of you already know what is a fuel cell, but for those who are not familiar with fuel cells, I would like to make some principles. And for the rest, so sorry, it's can use like a reminder of your concepts. We will pass quickly about the classification, the types of fuel cells that actually are in the market. And in this part, we will highlight which kind of fuel cells can be used for energy generation in isolated areas. And finally, I will give a personal point of view about the outlook for using on island. And if you have questions, we can answer them later. Okay, first of all, I would like to explain what INTA is. INTA is a public research organization belonging to the Ministry of Defense, and it's specialized in aerospace technologies, but also is working in other application technologies like aeronautical, space, land, and naval fields. Probably you have seen last week on TV the launching of the rocket Miura. So it has been launched from my center in the south of Spain and others. INTA acts as a technological center of the Ministry of Defense for those materials that I told you before. INTA is, let's say, the headquarters is located close to Madrid, in Torrejón de Ardoz, but is spread all over Spain, not only the peninsula, but also in Canary Island. It's like 20 kilometers from here, 20 minutes. We have a center in Maspalomas of space tracking station. We have also 3 more around Madrid, in Segovia, Robledo de Chabela, etc. And other technological centers like El Pardo. We were talking yesterday with some colleagues about the experience of El Pardo devoted to naval systems, sea and boats and so on. La Marañosa, who take into account the different research and development in terrestrial systems. We have also some other centers, like one at the north in Rozas, in Galicia, devoted to test unmanned aircraft. I have to tell you now, and announce is that next 25 of October will be the inauguration of one of the biggest centers in Europe for testing unmanned aircraft. The name is Zeus, and it's located like 8 kilometers from my center in Arenosillo. I'm talking about Arenosillo. Arenosillo is the center where I'm actually working in. It's close to the beach, also like this wonderful center ITC, where we develop the test of different energy systems and also unmanned aircraft systems. Well, this is an aerial view of my center. You can see it's a very nice place, also close to the beach. I formally invite you to visit us whenever you are able to, and we will show you our facilities there. INTA has been working in hydrogen technology and fuel cell for the last 30 whatever years, 32. We constructed the very first installation producing green hydrogen in Spain. It was the second in the world. It started in 1990 with the construction of a photovoltaic field that fed an alkaline electrolyzer directly, which is really difficult. And we produced our first green hydrogen, renewable hydrogen. Then we have been adding other renewable resources, like another PV, different kind of technology, PV panels, wind energy, and so on. And actually, all of them are integrated in a microgrid, who also incorporate different kind of storage, energy storage, like batteries, supercaps, etc. Also, we have been producing hydrogen not only with electrolysis, but reforming certain kind of fuel, like ethanol, methanol, natural gas, diesel. We had a program for the submarine of our Navy. We have been testing different kind of fuel cell, from alkaline, proton chain membrane, phosphoric acid. We have fuel cells test benches, also batteries, supercaps, test benches, climate change, so on. And some demo projects. Those are some of the renewables resources that we use, and some of the, let's say, more popular demo project is what you can see there. It's a Hercules project, consisted on the transformation of a regular four-wheel drive car into a fuel cell car. We made the transformation of this car, but not only constructed the car, but also the gas station, the photovoltaic field to produce the green hydrogen, etc. It was a very nice project. This one, we have also small cars fed with hydrogen to move for our facilities. Well, those are some other projects consisted on, let's say, facilitate the energy system to unmanned vehicles, ground vehicles, submarines, aircraft, etc., in order to increase the autonomy of those vehicles thanks to the hydrogen, the combination of hydrogen, fuel cells, and also batteries. I don't know if this is going to work. It's one of our toys. It's a robot. The original model is fed with some batteries, lead acid batteries, and we take out the batteries, throw to the rubbish, and install a small tank. It's the one that you can see there, of 7 liters, in a pressure of 350 bar, and install also a fuel cell inside the robot. The robot has a camera, a 360-degree camera with facial recognition, so it can patrol over our center, and if detect someone who is not our friend, make a call. Also has a LiDAR radar, has a GPS, so we can send a command in order to follow the how do you see that, the point, the tracking, so on. Okay, I will talk a little bit about fuel cells. Fuel cells is an electronical device that transforms the energy in the hydrogen molecule into electricity and water. The reaction is hydrogen plus oxygen, electricity, energy, heat, and also heat and water. So I will talk a little bit about the different components. A single cell, which is the simplest fuel cell that you can has, is an anode, a cathode, and in the middle, an electrolyte. The anode is the part where the hydrogen is introduced by some channels that they have. And thanks to the catalyst, the molecule of hydrogen is transformed into a proton, a positive proton, and electrons. The proton can move from the anode to the cathode through the electrolyte, but electrons are not able to pass through the electrolyte. So this is the reason why we circulate the electrons in an external circuit, and if you have conductor and electrons, you have electricity. So the electrolyte, the function of the electrolyte is to allow only the pass of the protons, but not the electrons, from one electrode to the other, from the anode to the cathode. The cathode, where protons are arriving, join with the electrons and with the oxygen, and is transformed into water. So water is the reaction, is what you can find in the exhaust pipe of the fuel cell. You generate electricity with a very high efficiency. And now I will talk a little bit about the different kind of fuel cells, different types of fuel cell. The very first is the alkaline fuel cell. Alkaline fuel cells are well known because they were the one that traveled to the moon with the Apollo rockets. So the Apollo rockets had an hydrogen and oxygen tank to fuel the rocket as well, but also take these two molecules, oxygen and hydrogen, to produce electricity and water from for the people living in the rocket. Mainly is used, as I told you before, in applications like spatial applications, submarines, because it has to be fed with pure oxygen and pure hydrogen, but not with air, because the CO2 containing in the air can react with the KOH electrolyte and form carbonate, and the carbonate is not very good for the fuel cell. The efficiency is very high, it's around 60%, but if you are able to recuperate the heat of the fuel cell, you can reach efficiency up to the 80%. It's what we call the combined heat and power use. So you can see an image of the very first alkaline fuel cell traveling in the Apollo rocket. You can see there where is located the fuel cells, and also in submarines can be used. Okay, in the second type of fuel cell that I want to explain you is the proton exchange membrane fuel cells, or PEM fuel cells. Those kind of fuel cells use an electrolyte which is a polyimide. It's like a, let's say, a plastic. It's not a liquid like the others. So this fuel cell also has a very high charge of electrolyte, of catalyst, mainly platinum. And the temperature of function is, can be lower, like 25, 30 degrees up to 90 degrees. The efficiency is not so good like the alkaline, but good enough, around 50, 60% also. And due to the facility to give the power immediately, very quickly, we can use them in automotive applications, mainly in cars, buses, or other applications like forklift or so on. But also in stationary applications. I mean, we can construct a power plant based on fuel cell and PEM fuel cell because they are big enough. You can see here the scheme of a fuel cell electric vehicle. You can see here the fuel cell in a Toyota Mirai. Here, if you open the part of your car, you can see this fuel cell in the Hyundai Nexo. And also it's used as a backup power unit in data centers or in communication centers. So it's one of the uses well extended. This is one fuel cell installing an antenna for communications. And this is an domestic use of a proton exchange membrane fuel cell for give to a house 5 minutes electricity and heat. Okay, next one, which is it's like a PEM fuel cell, but can use direct methanol instead of hydrogen. So mainly it's used for feed a laptop or small units of energy in remote places. You can see a laptop with this system. Phosphoric acid fuel cell. This kind of fuel cell were commercial like 10, 15 years ago, even 20 years ago. Used an electrolyte based on orthophosphoric acid, and the temperature of operation is 200 degrees. With this temperature, we are able also to recuperate the heat to produce energy in form of heat or cool for an absorption machine. Has been installed hundreds of these units. This is the PC25. It's a well-known in the market. It gives 200 kilowatts of electricity, but also heat in the form of heat water. You can see in the left part the reforming, gas natural reforming, because can be used with natural gas. In the center, the stack, and in the right part, the electronic device that transforms the DC current to the stack. This one, and we are increasing the size of the fuel cell, but also the temperature, is the molten carbonate fuel cells, well used for stationary application and to give power in some isolated places. This is a picture of a factory of a molten carbonate fuel cell. I had the opportunity to visit some of them in USA, and they really work to give a big amount of energy. This is a real plant based on molten carbonate fuel cell. At last but not least, the solid oxide fuel cell. This kind of fuel cell is the one that works with a highest temperature. It's around 1,000 degrees, which is a really high temperature. So we are having problems with some material, but they are going well right to the market. This is one of the Siemens. And And just to finalize, just to tell you, if you review the reports from different institutions, like for instance IRENA, which is the International Renewable Energy Agency, or the Clean Hydrogen Partnership, or whatever, even I have taken information from the electricity storage and from the Canadian Green Hydrogen Report. It's well documented that the use of fuel cells in island, like this one, will be the future. And the very first steps of the use of fuel cell will be given in isolated areas, like an island. So the Canadian Green Hydrogen Strategy gives a very clear message about the use of fuel cells. The first one is the use in transport. We know a really good example. Yesterday was, we talked about them. And the re-electrification of some part of the island where the electricity facility, the net, is not reaching because different reason, mainly for environmental problem or because of the network is weak, and this is where the fuel cell can play an important role. I think that's all from my side, and thank you very much for your attention.
Fernando Isorna, representing the Spanish Ministry of Defense, the Aerospace Technology Institute, INTA. Thank you very much, Fernando, for your very comprehensive review of all fuel cell technologies. Also for showing all, Fernando is a pioneer in hydrogen in Spain, and he showed all the work that he has been carrying out since 1990 at INTA with all these very interesting applications, especially to transport. And yes, and what about this CEO's testing unmanned vehicle? What role will hydrogen have on those vehicles?
Okay, we have been testing. What we do is to give solutions when they have a problem of energy. So if you have an unmanned vehicle and the autonomy is like 20 minutes and they need more time, so we try to give the solution. In that line, we have already constructed a couple of airplanes moving with hydrogen, and other like unmanned, little boats on the surface, or submarine, as you can see them. But I think that hydrogen in unmanned vehicles in general is a very good solution, basically to extend the range, the autonomy. And don't forget that fuel cells, for instance, the proton exchange membrane fuel cell, works with a very low temperature, and electric motor make less noise than an internal combustion engine. So when you are using in some military or security actions, you are using a drone. If the drone is electric and is with a fuel cell, the infrared sign is very low, so it's difficult to detect, and also the noise is very low. So that's the reason why we are playing with this system.
Gracias, Fernando. A pleasure listening. Very inspiring work you're doing at INTA. Thank you.
Thank you very much.
Okay. Sorry, something urgent came up, so we're trying to solve it, okay? Our next speaker, he comes from Italy, from a reference center for a European reference center. It's called ENEA. It's the Agency for New Technologies, Energy and Sustainable Economic Development of Italy. It's Dr. Alberto Iaconia. He's an expert on solar technologies, also on sustainable economic development, of course. He has been working on chemical, how softening chemical processes for reducing the environmental impact of industry. He has been coordinating different R&D projects at the European level. And he's also combining the work at ENEA with academic work at the University of Rome. He's, of course, a member also of the Hydrogen Task. And Alberto, it's an honor to have you with us today, and sharing also all these, the past days also, your presence here in the Canary Islands. So please, Alberto, the floor is yours. So.
Good morning, buenos dias, and thank you very much first for the invitation to participate in this very interesting conference yesterday, today, and also for the great hospitality. We spent wonderful days, very fruitful from the point of view of our work, also for the hosting the EXCO, our executive committee for the International Energy Agency on the Hydrogen Technology Collaboration Program. And, but it was really very inspiring also visiting your facilities. Yeah, I think you did a great job. As a researcher, I work in an applied research, and I think what you have done is a first of its kind, because it is from the chemical engineering point of view. I am a chemical engineer, and I see that combining several different packages is not so easy. Integration, you have been working in an off-grid environment. This is not easy, and integrate so many different technologies, and you did it. So congratulations. It was really inspiring. We are trying to do something similar, but I know this is not easy. So congratulations. So I hope this will have an important impact also for the future development of the hydrogen technologies with different applications on mobility, industry, ammonia production, fuel production, e-fuels, and so on.
Thank you very much, Alberto, for your kind words on behalf of our colleagues of ITC. For us, it's very important to hear the words coming from ENEA, okay? Because for us, it's a reference.
Thank you. So I have my slides. I can put in a general presentation today. I will brainstorm with you some considerations regarding the decarbonization of the transport sector. And I will spend a few words about what is going on in Italy, but I think we have a lot of points in common with several European and non-European countries on the decarbonization of this sector. So first of all, I would spend a few words about what is going on in the world. We can see that today, in general, there is a growing trend on the hydrogen demand. Today, in the world, are produced and consumed about 100 million tons of hydrogen. This is already happening today. So this is not the future, it's today. And today, the hydrogen is produced and used, and mainly this is produced through to satisfy the demand from a chemical industry. Still not much mobility, but where does this hydrogen come from? It comes from as a byproduct from refineries, polymer industries, chloroalkali processes, but all this byproduct is not enough. Today, it's not enough to satisfy today's demand. As I said before, we have 100 million tons per year of hydrogen demand, and this requires an additional hydrogen production that will come from mainly through natural gas steam reforming or other devices that produce carbon dioxide and have an impact on the environment. And we know if we make a simple calculation, 100 million tons of hydrogen, 1 ton of hydrogen produces around 10 tons of CO2 in a conventional production methods. And this, in the end, accounts for 2 to 3% of the total greenhouse gas emissions. And this is today. So if tomorrow we want to achieve what we call the net zero carbon scenario, at least we have to decarbonize the hydrogen industry, changing from actual fossil fuel-based hydrogen production to a completely 100% green hydrogen production. But we see that the world is changing, and there will be an extra hydrogen demand coming from what we call the hard-to-abate sectors. Why that? What is this? It is now several years, decades, that that we started the decarbonization pathway. We know that. And what we can feel and what we can see is that what we are trying to do is to electrify as much as possible the end users. So electrification of the end users is already currently going on. We see, for example, in the mobility sector, plug-in electrical battery vehicles are being produced, and this will change for sure the scenario in the transport sector. And in the meantime, we are increasing the footprint of the renewable energy in the electrical system. So step by step, we are gradually increasing the impact of renewable sources in the electrical system. So indirectly, this will determine the decarbonization of the end users. However, there are some sectors that are considered as hard to abate because that will not be possible to decarbonize some sectors like, for example, industry and mobility completely by electrification. We need something different, and hydrogen is a solution. So we need to install additional electrical power or renewable energy capacity in order to satisfy the additional demand coming from what we call the hard-to-abate sectors. And this is industry, and this is mobility. And in the case of mobility, of course, we can consider this kind of decarbonization by means of fuel cell electrical vehicles, but also there will be still some use of internal combustion engines, what we call the e-fuels. E-fuels may be ammonia, but also liquid hydrocarbons synthesized by the reaction between CO2 and the hydrogen, as we'll see later. And why that? Because there are some transport sectors in which it is difficult to apply directly hydrogen or green hydrogen. This is the case, for example, of aviation, where there is a demand for what we call the sustainable aviation fuels, or ships, boats. It is possible that in the future it will be for boat transportation necessary to apply this kind of liquid fuels, more similar to what is conventional fuels like heavy oils, but synthesized not from fossil fuels, derived not from fossil fuels, but from hydrogen. So what is going on now? It is well accepted today that the direct electrification of the transport sector and the use of renewable fuels will have a kind of complementary role. It is well accepted that light battery plug-in electrical vehicles charged with renewable energy will be a solution. But still, internal combustion engines using what we call renewable fuels will be still necessary for aviation, for maritime, or even also for heavy transport. So what are these renewable fuels? Renewable fuels are basically biofuels, of course, fuels derived from biomass, or what in the acts, also from the European Commission, is defined as a renewable fuel of non-biological origin. And this is hydrogen. And these are also the e-fuels. So we have two options, biofuels or synthetic fuels. Still, they can be very similar to conventional fuels, so this does not imply a very important change of the infrastructure, of the transport infrastructure. But the origin is very different. One is more biological, one is more, let's say, chemical. But today, in Italy, for example, there is a very lively discussion on what is the scenario, what will be in the future, what will happen. Do we have to push do we have to rely on a strategy based on the biofuels or hydrocarbon derived from biomass, or working on something like e-fuels, liquid e-fuels? And this is a very interesting debate. Also at the European level, there is a strong discussion in these days on the roles of the two different approaches. Let's see what is happening, for example, in Italy. In Italy, recently, this summer, there was a submission of the revised draft of the National Plan for Energy and Climate. And regarding the use of biofuels, you can see in this graph that there is an important, in the future, by 2030, it is seen that there will be an important increase on the use of and the production of biofuels for transport sector. But in the same time, there will be also the utilization of biomethane produced from biogas refining as an option for the transport. And of course, there will be also an important increase on the use of electrical plug-in vehicles. And we know that many car manufacturers are producing and distributing electrical cars, and also the recharging infrastructure is well developed, or is going to be developed very, very quickly. But still, we can see here, we have what we defined before, the renewable fuel of non-biological origin, and this includes hydrogen. So this is already mentioned and considered in this National Plan for Energy and Climate. And after 2025, it is expected that there will be a linear increase of the use of these synthetic fuels. So again, biofuels or synthetic fuels. What is the situation? Today, we are still far from this scenario. In Italy, for example, we only have 2 hydrogen refueling stations, public refueling stations. One is in Sanremo, the other one is in Bolzano. 30 fuel cell cars, as far as we know, and 14 fuel cell buses. This is not good. If we compare to other countries like France, Germany, we are very far from the target. So this means that we need to invest first on the refueling infrastructure and then on the mobility sectors in general. But the good news is that with the Italian National Recovery Plan, there have been some calls for projects to develop infrastructures, what we call the valleys. And in the valleys, it is considered also the possibility to produce and deliver hydrogen for the transport sector, for the mobility sector. And if we want to achieve the objectives of 2030, already we have to increase very much the hydrogen production. We need additional 250 kilotons of hydrogen produced every year in Italy, and 80% is domestic. And in the end, this requires the installation of more than 3 gigawatts of electrolyzers. And you can see here in this table that more or less more than half of the hydrogen production that we expect by 2030 is addressed to the transport sector. So this is an important and ambitious target, especially again considering that we are starting from a very, very low level of infrastructure. So let's now consider the dilemma that I mentioned before: biofuels or e-fuels. Well, in Italy, as I said before, there is this discussion, but in Italy, the strategy started some years ago is pushing on the production of what we call the biofuels. For example, Eni holds 11 refineries in Italy, and 2 of these refineries have been already converted to biorefineries. So there is a clear trend on the production of biofuels like biodiesel in Italy, and this is the reason why, in principle, the use of biofuels in the future is considered as a main pillar for mobility. And also, okay, we have biorefining, but we can also consider the gasification of solid bio wastes. And so we know the gasification, production of syngas, hydrogen, and then Fischer-Tropsch, for example, for the production of fuels. But what happens? Now we can see that there is sometimes we do not have 2 different choices, biofuels or e-fuels. Sometimes there are 2 possible approaches that can be combined. And let's see, for example, the production of e-fuels or methane or synthetic methane or methanol using synthetic gas from biomass gasification. As we can see here, if we want to best valorize the carbon dioxide, or in general the carbon that is contained in the biomass, we need some extra hydrogen. And this is also in the biorefineries. Biorefineries need extra hydrogen. This has to be green hydrogen, and this has to be produced, not of course from biomass, but from electrolysis. So this means that the 2 value chains, the 2 ways to produce fuels must be combined to best valorize the carbon dioxide. Let's see, for example, here. In the biomass gasification, we have usually a syngas with a hydrogen CO2 ratio about 1. But if we want to produce a biofuel, we need a hydrogen to CO2 ratio about 3. So this means that we need extra hydrogen to be supplied to the system. And this has to be done with a power-to-gas approach. So we are doing some research in different programs in Italy, also research on the storage, transportation, and e-fuels in a big program funded with 110 million euros. So this is currently the research that we are doing, and from the, of course, from the e-fuels side, we can see, okay, let's imagine that the world in the future will be completely decarbonized. So where does the CO2 come from for the synthesis of the e-fuels? E-fuels, the recipe is considered the combination of hydrogen, okay, produced with electrolysis with the CO2, but where does the CO2 come from? Where does the carbon dioxide come from? And it can come from, of course, if we don't have greenhouse gas emissions, this can come from, I don't know, onboard carbon capture and storage. On big boats, we can capture the CO2 that is produced, or direct air capture, but this is challenging. And so, in the last slide, I can show what will be the impact of the CO2 in hydrogen production. If we want to produce 1 kilogram of e-fuel, our recipe says that we need 3 kilograms of CO2 mixed with 1.43 kilograms of hydrogen. And this means, in the end, that we need in the final cost of the e-fuel, we not only have to consider the cost of the hydrogen, but also the possible cost of the CO2 that has to be delivered. And so this is another example on the reason why we need to combine the biomass pathway with the power-to-gas pathway in order to have a best combination and reduce as much as possible the cost of the e-fuel. So said that, I just can summarize the conclusions that in Italy we need to install 3 gigawatt electrolyzers to fulfill the 2030 objectives, and this is an ambitious program. And but this is already ongoing, and the decarbonization of the transport sector requires complementary use of biofuels and e-fuels. And of course, I showed you the interplay between the biofuels and the e-fuels and the role that CO2 and green hydrogen will play in these two scenarios. So I thank you very much for your attention, and happy to answer your questions.
Alberto Iaconia from Enea, Italian reference institution at the European level, at least, no, worldwide too. Alberto, very interesting perspective and vision, especially regarding what you just mentioned about the dilemma, the dilemma between biofuels and renewable fuels of non-biological origins. And well, just the figures you show, I mean, it would not be easy to get these biofuels, both in terms of energy needed and also raw materials that will have to be, and also CapEx. I mean, you need to install equipment, reactors, and this is expensive equipment, but the Italian government is committed to get the 3 gigawatt installed by 2030. In the short term, I guess when you mentioned the National Recovery Plan, I guess it's partially financed by the European Next Generation Funds for Transition and Transformation, no?
Yeah, this is correct.
Yeah.
This is correct. And this views both research and development activities and also industrial initiatives on the larger scale.
Okay. And Alberto, you also mentioned, I mean, that the priority now is to decarbonize, to go to a net zero in the basically prioritizing industry, substituting the gray hydrogen for the green one. But we need more pathways in order to totally decarbonize not only industrial processes, but also transport. No? So thank you for your vision and for your perspective, Alberto. Very interesting.
Thank you. Muchas gracias.
Okay, so now from Portugal, we have Francisco José Magalhães. He's from Caetano, hydrogen manufacturer, a bus manufacturer. It's a reference. He will tell us the different ongoing projects that are being developed, at least at the European level, where Caetano is somehow a technology provider. In our case, we had this tender process for a hydrogen bus, and Caetano also was allocated the public contract. No? Caetano bus, as we mentioned, is a reference. Francisco, he will tell us about opportunities for decarbonization of collective inter-European road transport sector in islands through green hydrogen. And Francisco, I am going to apologize publicly with Francisco, because the idea was we already have the Caetano bus here in Gran Canaria. The idea was also to bring it here to our facilities during the morning, so Francisco could show us the bus, but unfortunately, again, my fault, some logistics will not allow. And Francisco, he has to rush. He has a flight early in the afternoon at 13 hours. So, Francisco, we will not take more time, so please, the floor is yours.
First of all, Salvador, Santiago, thank you very much for the invitation to be here today at ITC, the Technological Institute of Gran Canarias. It's a pleasure to be here. As Salvador presented me, I'm from Caetano, a zero-emission OEM nowadays. Before a traditional bus bodybuilder, and nowadays a zero-emission OEM. We have been focused over the last years on development of zero-emission buses and coaches. And naturally, the roadmap we have planned is towards exactly to have a complete zero-emission product portfolio within the next few years. Sorry. Going through my presentation. Just check, where is it? This one here. Very good. Regarding Caetano, I will make a kind of introduction about what are the main challenges regarding the introduction of zero emission and also hydrogen fuel cell buses on the traditional mobility of public transportation. Like our founder one day said, today as before, our focus remains on the future. One of the main characteristics of Caetano is that we have been always in front of the new technologies and trying to introduce the best and last state-of-art technologies in the products we supply everywhere in the world. Just to give you a clear perspective about what is Caetano. Caetano is nowadays is the biggest Portuguese manufacturer, bus and coach manufacturer, and one of the oldest in Europe. We have more than 75 years of operation. And clearly we have two brands nowadays, the airport brand that we have with the Cobus, the airport bus we also have on zero emission, and also the Caetano brand we have operating worldwide in every city, road cities. Also regarding the structure of Caetano nowadays, and this is the reason why our buses are badged with the Toyota logo, since 2019, Caetano have one of the main shareholders being Toyota Caetano Portugal, which is also shareholded by Toyota Motor Europe and by the holding Salvador Caetano Group, and at the same time also by the Japanese investment group Mitsui. As mentioned, we have started this zero-emission production or challenge 40 years ago when we developed the first trolley buses, but more recently in 2010 we've decided to move definitely to these projects of zero emission. So we started to developing, as everyone did, battery buses, and in 2011 2019, we have launched and introduced our first fuel cell bus. It's a typically city bus operation bus, and this was already launched in 2019, which is a milestone quite important because nowadays we have more than 115 already fuel cell buses running all over the world in real operation. Like I mentioned, Toyota and Caetano have established a kind of alliance to boost the hydrogen usage on public transportation, and at the same time to ramp up all the usage of the zero emission technologies in the future. As mentioned before in this conference, the future of hydrogen will have their specific role on the zero emission. We can't say that the hydrogen will replace the battery buses, for example, or the electrical battery vehicles, but it will play a very important role, as I will explain after, on the zero-emission mobility because it's one of the solutions or the existing more reliable solution to provide the operators and the users a longer extension range of operation. So here is more or less the roadmap of the products of Caetano we have. We have more than 45 cities with zero-emission vehicles. And as you can see, it goes from Australia to the North America, and also in China, where we have some EV electrical cobos operating there. Thinking about the hydrogen, we have more than 150 units, mostly located in Germany, Spain, and also France now, which is still not showing here with the complete numbers. And as you can see, we also have some solutions available and operation in Saudi Arabia and Australia. In Australia, it's a very important market, in fairness, exactly because of the availability of grids, electrical grids, and the extension of the country. So it's one of the countries where we are putting more enthusiasm in the zero-emission mobility also. And as mentioned here, in Spain is one of the main leading markets in Europe for the hydrogen already. Speaking about the particular fuel cell bus that you'll have the opportunity to take a look afterwards, this is a city bus, M3 Class 1 bus. It's a typical urban bus for operation, which is using a Caetano EV electrical chassis. This electrical fuel cell bus is having the possibility to a launch of minimum ranges of 450 kilometers. It's fitted with 5 tanks at 300.5 kilos of hydrogen on the top of the roof at a pressure of 350 bar and having 3 packs of batteries with 44 kilowatt-hour solution, LTOs. The fuel cell stack is a PAM fuel cell stack from Toyota, the same fuel cell stack that is supplied on the Mirai, but with a different architecture and programming exactly because of the type of operation of vehicle. One of the biggest differences between battery buses and fuel cell buses when it comes to operation, and we have here Guaguas Municipales, for example, is the refilling time. The refilling time of a fuel cell bus with the infrared system on the refilling station can be less than 10 minutes. When we think about a battery bus, which is a different concept, it takes 4 hours at least just to recharge the batteries. So on the operation point of view, for an operator, and I will show it afterwards, there are important challenges on the decarbonization of their fleets. Here is a kind of diagram about how it works, the fuel cell bus. So the electrical energy, the chemical energy from the hydrogen is transformed or produced on or changed to electrical energy from the stack. And this energy that is supplied to the vehicle, the energy that is not spent is stored on the batteries, and also the energy that is regenerated from the braking and the acceleration systems is also stored on the batteries. So basically there is a power module that will make all this management of energy in the bus and will lead to a consumption that is optimized already at this stage of the hydrogen in the vehicle. As you can see here, you have clear the architecture of the bus. You have all the fuel cell system and high voltage system fitted on the roof. And clearly inside, when you have the opportunity to take a look on the bus, in Italy, this bus is already also available soon. So as you will see inside the bus, you don't notice much difference from the traditional bus. You have the seats, you have the low floor chassis, you have the low floor flow for the passengers. The access for the passengers is very normal, but the internal appearance from a fuel cell bus, from the interior of the bus, is very similar to the traditional buses. The main difference is that we have hydrogen in this bus and we have water out. Basically, the exhaust system of this bus, let's say, everything that comes out is water. Another important factor is the operating temperature ranges for this type of bus. It's not new that sometimes EV battery buses, they struggle to operate on very cold countries and very hot countries. The main consumers of the energy available on the vehicle, being electrical battery bus or fuel cell bus, is coming from the heating and cooling systems. These are the main contributors, apart from the driver and his food, the main contributors for the consumption on the bus. Okay? When we think about what is the current flow inside the battery with very cold temperatures, the intensity of current drops significantly with very cold temperatures. So that's why we had news some years ago about electrical buses being stopped in Berlin and other German cities on an extreme cold climate situation. On the opposite, all the equipments that are fitted on the fuel cell buses are prepared to operate for a range between minus 40 degrees to up to 55 degrees. So we can say this is the type of technology and type of bus that is ready to operate in Lapland, in Laponia, in Santa Claus Land, and at the same time in Dubai. So clearly it's the type of solution that is more flexible for an operator to be comfortable to operate this bus. Naturally, there will be a higher or lower consumption of the hydrogen in the bus, considering the time of the year and the operating conditions and temperature conditions. But it's more stable and more flexible than exactly operating a pre-stored energy solution like the battery buses, and with a limited range. This is one of the main characteristics too. So, let me just try to see. This is strange. I will give you a perspective because there is a slide that is not showing. I don't know why. But the fuel cell coach is the one we have presented recently in Busworld. It's the next step of the hydrogen buses or coaches. The fuel cell coach is the type of vehicle that is more operated, for example, here in Canarias by Global Bush, the operator that will be operating the ITC fuel cell bus, and is focused on intercity commuting systems. It have normally ranges that can reach up to 1,000 kilometers in a row. We will have a dual pressure system on this coach that will operate on 350 bar and 700 bar. Naturally, the amount of hydrogen stored will be around 40 kilos. There will be 2 fuel cell stacks with 140 kilowatt power in total, which will provide also the energy efficiency and power for operate a bus that normally has a speed that can reach 100 kilometers and is more focused for operations on highways. Also, at the same time, we'll have bigger battery capacity on this bus, exactly to extend the energy storage of this bus in the of this coach in the operation on the long range operations. One of the most important things on the coaches and buses of fuel cell is always making sure that the energy available that is stored on the batteries is there, and at the same time that the fuel cell stack is producing enough energy to guarantee that the vehicle is kept running and not entering on a safe mode. This is training for the drivers, but at the same time, it's one of the situations that is particular on this type of buses. So thinking about what will be the future of the fuel cells, this picture is quite known, and it's showing an electrified depot to recharge battery buses. And then here on the side, I believe it's visible, you have all the area that is taken for hydrogen filling places. Land is expensive. Depots are limited size. So one of the challenges for most of the operators normally is related to the refilling or recharging infrastructure. This is another characteristic besides the time for refueling. When an operator needs to think about electrification, he needs to think about what will be the space taken by the infrastructure and the investment associated to that. As we can see here, the space taken on the depot for hydrogen refueling station is not much different from what normally the operators have with the traditional CNG buses. And when you think about electrification, we have the complete depot covered with the chargers and the recharging systems. And this is one important feature. Like I mentioned before, one solution will not replace the other, but will strongly complement. So the hydrogen is bringing a different level of the decarbonization on the public fleets and private fleets. But when we think about small cities with limited fleet numbers of buses operating in a small shuttle service with low mileage, it makes no sense to invest on hydrogen, clearly. But when we think about commuting cities or connecting cities of the same country or internationally, for example, we cannot exactly think on battery buses. How can we explain to a passenger that after 4 hours in a journey, you will have to stop, or after 400 kilometers in a journey, you will have to stop for 4 hours because the bus needs to be recharged? This will be a challenge because normally what this means that there will be needed spare buses and more investment from the operator exactly to have the same type of operation. Saying that, we can establish some kind of parallel because the operation the operators have nowadays with diesel buses will be the closest they have on hydrogen, okay? Also, the charging time, or refueling time, it's much different. And like I mentioned, the temperature is also a strong challenge. This is the perspective on comparison when you have to replace 50 diesel buses. You replace 50 diesel buses by 50 fuel cell buses. Of course, you can always have 1 or 2 spares for maintenance programs. But when we have to think about battery electrical buses, you need to have some more spare vehicles. And this is quite significant. It's 30% more fleet just to make the same type of operation. After the COVID, or during the COVID, some of the operators in Spain were facing the fact by having to travel with the window hoppers open, they were reducing the traveling time in 1 or 2 hours a day. Of course, the price competitiveness is one issue. We still have fuel cell buses more expensive than battery buses, but if we transfer the OPEX of replacing the batteries by midlife to the CAPEX, normally what we have is some price leverage between fuel cell and battery buses. The other challenge is the lack of infrastructure in many countries, like it was mentioned before in Italy. In any case, in Spain, there is a strange push at the moment for infrastructures. Places there are already infrastructures in place, in Barcelona, in Toledo, in other cities, in Las Palmas, of course, thanks to ITC. But we having a strong movement of new technologies in Spain and new investments on the infrastructure in Spain. The traditional fuel suppliers are also strongly investing on the infrastructure, and this is a good sign for the market. Basically, the next solutions are inventing the business or reinventing the type of business. Zero-emission business is very different from the traditional business. Operators, manufacturers, energy suppliers work together to make the optimization of the complete process. The CapEx has to be seen more like a TCO basis, and new solutions of business are being provided. Instead of the traditional purchase of vehicles, for example, and then purchase of the infrastructure, what is already being discussed and proposed is a solution like one-stop shop or mobility as a service. Basically, the operators will have buses, infrastructure, fuel maintenance on a price per kilometer, which is much closer to what they have nowadays in their operation. This is an integration process between bus manufacturers, energy providers, and operators, of course, and of course the finance institutions that will be the cap of all this process. Clearly, it's not anymore exactly chicken and egg because the hydrogen is becoming available, the buses are already fully proved, and we believe strongly that the future of the long range, at least long range operation buses and coaches will be moved on hydrogen. It's important to think that the hydrogen valleys are really important for this process because when we create a hub to guarantee the consumption of hydrogen, joining buses, garbage trucks, forklifts, supply of infrastructures of hospitals, supermarket lorries, things like that, are all an ecosystem that it's very important for this type of projects. Also on the airports, all the handling equipment combined with buses and coaches is a guarantee of consumption of hydrogen on a yearly basis. As I mentioned here, mobility as a service is basically combining all the systems into one price. And this is the most comfortable solution for an operator. Thank you very much. And as I mentioned, the future developments of Caetano will integrate all the type of long-range and high-dimension vehicles. Thank you very much. And I think I managed to escape the last 5 minutes.
For us, always a pleasure having you, Francisco,
Thank you
here
for
with
the
us. And Francisco José Magallá, I'm sure I'm pronouncing your last name not correctly, no? Magallá.
You can pronounce Magallanes, Magillian, whatever you
Magallá
want. Everyone will know it.
Thanks for the flexibility,
I
Francisco.
lost my grandpa in the Pacific. So.
Okay. So International Sales Manager for Caetano. And well, just impressive what you have been doing, and we as final off-takers, we appreciate all the technology providers having companies like Caetano showing Portugal technological strength also. I mean, it's important that we also know that Portugal is also investing hugely on the transition and all these technologies to have a more sustainable energy system, including transport and exporting that technology to the rest of Europe and the rest of the world. No? And so, well, he showed us of ongoing projects where Caetano is the technology provider. Many European cities, we show, well, beginning with Cascais, beautiful place in the outskirts of Lisbon, also a very nice city, but Cascais is very special. Well, Madrid, Copenhagen, different German cities. and how the hybridization of the bus is not only hydrogen versus batteries. In the case of Caetano, the optimal solution has shown that hybridizing with those 44 kilowatt hour, the 37.5 kilogram hydrogen storage proves to be an optimum. So in that sense, it's not, I mean, complementary technologies also sometimes, but he has a point. I mean, the time of charging batteries with respect to the time for refueling hydrogen, less than 10 minutes, compared to 4 hours maybe to charge a similar energy content to make those 450 kilometers of range. That's a strong argument. And he also pointed out to the fact that expensive city land, scarcity land, is also playing in favor of hydrogen refueling stations when compared to electric vehicles, especially those big vehicles like buses, heavy trucks. That's where hydrogen really proves the certain limitations of the lithium-ion technology when we want to electrify those heavy transport systems. And the importance of advancing in the whole ecosystem. We have to look for an equilibrium in all the hydrogen value chain, especially when addressing hydrogen transport. We have to focus on the upstream, of course, of renewable energies, hydrogen production, but also distribution and the final off-taker. I mean, if we want to advance, like our previous Alberto speaker told us they're doing in Italy, we have to advance in the whole value chain. We have to publicly support not just the production of hydrogen, but also those final off-takers with generous public support so we can kickstart all these hydrogen transport systems, in our case, in islands. Mm-hmm.
Just three main topics. We have to understand how the cities are growing nowadays. It's becoming, in general ways, it's becoming very expensive to live on the city centers. People are moving to the suburbs. So before, a bus line, that was having 200 kilometers range. It's increasing up to 350 kilometers sometimes. If we think about, let's go for the capital in Madrid. Most of the CRTM operations, some of the CRTM lines have nearly 500 kilometers a day. It's inside, let's say, the big Madrid, but it's Madrid. We have to understand that we have nowadays some lines that are as long as some coaches are making on a daily basis. On the other hand, when we think about the investment on the infrastructure, before, on the battery buses, normally the investment on the infrastructure remains with the operator. On the fuel cell, we can always have, let's say, a semi-public infrastructure for refueling. It can be used by cars, it can be used by trucks, it can be used by the public transport company, bus company. This is another issue. And again, the flexibility of the operation. When we think about the business model, this is a reinvention of the business model. It's no longer the pure purchasing process. It's thinking about how do I optimize my investment. Mm-hmm. We have to bear in mind that 40 kilometers more represent, on a range, represent a strong investment on a battery bus, for example. Mm-hmm. And the grid in the cities, most of the times, is not prepared for, from one day to the other, everyone is charging their bus or their car overnight. Where is all this energy coming from? What kind of pressure are we putting on the grids? So the hydrogen plays a very important role to release all this pressure from the traditional electrical grids. We have to bear in mind that most of the countries in Northern Europe, the very sophisticated countries, most of the cities are not prepared from one day to the other. Suddenly, all the cars are electrical and everybody's charging the car overnight, at home or in a parking place. So the hydrogen has a strong role on this.
And yeah, and also from the perspective of energy efficiency, moving to public transport, we need to do it also. It's not only switching to clean fuels, but also the mentality of maybe using more public transport. Thank you very much. It was a pleasure, Francisco, to hear your presentation, and thank you for coming.
Your pleasure.
Where are you flying now? To
Mine.
Lisbon?
I'm going through Lisbon.
Lisbon.
I'm flying to Porto, but through Lisbon.
Through Lisbon. Okay, thank you,
I
Francisco.
always have to pass by somewhere.
Always moving around, yeah.
Thank you.
Yeah, so our next speaker is the last presentation before the coffee break. Then the next speaker, he comes from the island of Tenerife, together with Gran Canaria, the two big islands of the Canary Islands, very beautiful island. And his name, Pedro Apeles, from the Island Authority of Tenerife. And Pedro, he coordinates the Office of Renewable Energies and supports the Covenant of Mayors European initiative for the Island Authority of Tenerife. He will be talking about developing new business models associated to the production and consumption of green hydrogen and biofuels in the island of Tenerife. And also he will brief us about energy planning in Tenerife, okay? So Pedro, the floor is yours.
Thank you, Salvador. I would like to thank the ITC and Gonzalo and you for inviting us to this presentation. It's a pleasure to be here. I'm going to speak about the development of new businesses models associated with the production and consumption of green hydrogen and biofuels in the island of Tenerife. First of all, I would like to introduce the Renewable Energies Office and Support for the Covenant of Mayors in Tenerife is an office of the Cabildo of Tenerife, and we are part of a thing that's coming to a network of energy transition offices in the Canary Islands. Here in Gran Canaria, they have the Energy Council, that they have the OTC, and in the Canary government, they have the green offices of Canary Islands. We give support and advice to the public, to the municipalities and the Cabildo about renewable energies, energy efficiency, sustainable mobility, energy communities, and we also coordinate the Covenant of Mayors in the island with the municipalities. We are 6 engineers and 1 architect. We depend on the Cabildo of Tenerife. And we also have the Observatory of Climate Change and Energy of Tenerife, in which we put information about climate change in the island of Tenerife, the energy sector, sustainable mobility, the state of the Covenant of Mayors in the island. And we also have an energy poverty observatory. And we are a participatory clearinghouse, so you can send us any information about hydrogen, for example, and we can put it in the observatory if it's a good study or something. Okay, I'm going to speak about the state of the art of the hydrogen and the energy sector in Tenerife. In Canary Islands, we only have a 5.6% of renewable energies in the final energy of all the energy that's consumed in the islands, and 94% it comes from fossil fuels. So we come from a situation in we had a climate energy, but we are also facing an energy emergency, a climate emergency, and we are also facing an energy emergency because, as we saw during the Ukrainian war, the start of the Ukrainian war, the prices of energy skyrocketed. And for example, we depend strongly on, for example, water desalination. and we saw, for example, that the price of water soared. So we are extremely exposed to these geopolitical situations. To see in which sectors we can use hydrogen in the island or in Canary Islands, we face a situation in which the transport sector supposes 71% of all the energy that we consume in the archipelago. We rely on the tourism sector, and this economic model give us this distribution in which residential, administration, and services are the only economical activity that we have, and all and the rest of the economical activity comes in small percentages of industry and agriculture and ranching, for example. The electricity, the form of distribution of this energy comes in 22% of electricity in the island of Tenerife, and we only have of this electricity at 21% of renewable energies in the mix of the island. This gives us the situation in which we have 900,000 inhabitants in Tenerife, and we have almost 800,000 vehicles. So we are facing problems of traffic jams and many problems with the private vehicle. And we also have the other face of the coin, in which in Canary Islands, we are receiving 12 million tourists that you have to give them the services and the food and the transportation for all of these people. We have made a study of the energy that computes in the CCAPs, in the sustainable energy plans in the Covenant of Measures, and we are seeing the same results. The transport in the municipalities is the main source of energy consumption and CO2 emissions. And what's the plan for the future? As ITC has developed, or the Canary Island has developed with the ITC, we have the energy transition plan on the Canary Islands, and on all of these sectors that we have seen, the hydrogen comes especially for the transport sector, as we saw, especially with the maritime transport, air transport, and heavy load transport, ground transport, in the form of ammonia, synthetic kerosene, and hydrogen. The private cars are supposed to be fueled by batteries, principally, in this plan. And we can see that the Canary government had the commitment for the Canary Islands to achieve the full decarbonization by 2040. In the alternative 2 of the plan, in which we can see that we have two slopes for the development of these technologies. One that's going to be slower until 2030, and another one that's going to be faster until 2040. And for 2030, the situation will be that we will have 200,000 electric vehicles and 7,000 hydrogen vehicles, more or less, and 17 hydrogen stations. And this is the situation nowadays in Tenerife. We have an exponential growth of the electric vehicle. We are facing that at the end of the year we may reach 4,000 vehicles, while the hydrogen ones still are insignificant. We only have two vehicles in the island. This is mostly in part because electric vehicles cost less, as you can see, and these are the prices for the fuel, so the electricity and hydrogen. with the prices that are today here in the island. For example, in an electric vehicle in Tenerife, if you charge it from the network, we have 2 euros per 100 kilometers, and this price of 17 euros per 100 kilometers was updated with a price that gave me in Titsa yesterday, in which the price that the hydrogen suppliers are having nowadays in the island is this price. I know that in the mainland is a lot lower, maybe 8 euros per 100 kilometers, but this is the actual price, and there are no refueling infrastructure in the island. This is a draft infography of the recharging, the charging network that we are designing for the electric vehicles. We have planned 30 slow charging stations and 17 fast charging stations of 50 kilowatts. This is all draft, even the logo and the location, because we are developing this network. And now I'm going to talk about the projects that are being developed by the Cabildo of Tenerife, not directly, but with its public institutions like the ITER or TITSA that we are going to see now. In Canary Islands, we have the Renewable Hydrogen Hub Cluster project. This project is promoted by DISA and Enegas Renovable, with the participation of many public entities and authorities, like the ports of Tenerife and Las Palmas, the public transport sector, and the shipping sector, car sector, and the tourism through ASOTEL, the Hotel Association of Canary Islands. We have the Cabildo of Tenerife has its representation through TITSA, that's our main public bus company in Tenerife, and through ITER, the Institute for the Technological Institute for Renewable Energies. We also have the participation of the universities of La Laguna and Las Palmas, and the ITC, and the digital participation of a digital partner, that's Telefónica. This cluster consists on developing projects for producing hydrogen with renewable energies, with water desalination, and compressing it and distributing it through buses to hydrogen stations for private transportation, public transportation, to fuel cells for example, coal ironing in ports, in the ports of Granadilla, Tenerife, and Las Palmas. For the ant industry in Canary Islands is not very relevant, but there are some ant industries like the glass sector, for example, that needs heating for the melting the glass. And there is a project of a propane air network for hotels in the south of Tenerife, and it can also be used for bunkering in port services. They have two main projects, one in Salinetas Industrial Estate of 2.5 megawatts with an estimated production of 225 tons per year. And in Tenerife, that had the declaration of project of island interest by the Cabildo of Tenerife to develop the urban plan of the area in which they have this hydrogen plant. But this is not an easy path. They are having a lot of problems. For example, they opted for the H2 Pioneers grant, in which for the first call they were not selected because they had problems with the grant regarding that it was designed for great industries in the mainland. So the project do not fit perfectly this grant, so they were not selected because they were not correctly evaluated. And they are waiting for the second call resolution that it has its limit in December. Another project that we are developing through the ITER, Instituto Tecnológico de Energías Renovables. It's an Interreg funded project that's called the CFUEL. The CFUEL has the participation of the ITER and with some universities in the United Kingdom and with the participation of the port of Tenerife and some car manufacturers. They had an hydrogen station. Firstly, they had planned to buy 5 cars, but they only had two electric cars converted to hydrogen cars through a fuel cell stored in the roof of the cars, as you can see in the picture, and another car that's a Renault Kangoo that has the fuel cell inside. The hydrogen station consists of a PM electrolyzer that has a maximum storage of 30 kilograms at 450 bars with a peak power of 100 kilowatts and an estimated production of 12 kilograms of hydrogen per day at 350 bars. It's a pity because it never worked, so they had to return it to the United Kingdom and it's being repaired, and they think that's coming back to Tenerife in the near future. Another project that ITER is developing is the Liquid. Liquid is a project in which, with a microphone array and humidity and temperature sensors, they can detect leaks in hydrogen storage facilities or facilities, so we can increase security, reliability, and efficiency of the system. Another interesting project is Eneport, in which through the Institute of Technology of Galicia and with the participation of ITER and the port of Tenerife, they are developing projects of offshore and onshore renewable technologies, hydrogen storage and storage or production systems in the ports, and supplying for maritime and land transport in these ports, and digitalization and artificial intelligence for an efficient management of all of the system. Especially ITER is collaborating with this last point, in which they are developing all the system that is managing all of these projects. The main projects are going to be developed in Granadilla Port in Tenerife, in Ferrol in Galicia, and in Leixões in Porto. For the TITSA public transport company that we have in Cabildo of Tenerife, we had a public tender for the supply and maintenance of 4 hydrogen fuel cell electric buses under hydrogen supply. They had a market carry of the price of the hydrogen that was 14 euros per kilogram of hydrogen, and it was distributed in 3 batches, one for the buses, for 4 buses, and the third batch for the 5-year hydrogen supply. The first batch had offers of Solaris and Caetano, but the third batch was null, so the whole project couldn't be developed because it had no, you cannot buy the buses if you don't have the hydrogen supply. Okay. Okay. And I am finishing. TITSA is also developing a project for the use of biofuels, mainly with Repsol, with many companies, but Repsol is the company that's giving their offers. And the last project is in the Tenerife Environmental Complex. We are using biogas with 2 internal combustion motors that give us 600 kilovolts of power, and we have a project for increasing this power with 800 kilovolts amperes of a biogas turbine for 800 with a total power. A total power of 2,000 kilowatts of production. That's giving us 1,200 megawatts per hour per year. And that's all. Thank you very much, and feel free to ask any question if you want, and thank you very much.
Yes, so thank you, Pedro Apeles, representative of the Island Authority of Tenerife, for your very comprehensive picture of the current situation and how the Island Authority of Tenerife is looking forward to advancing in the goal of very ambitious goals of a total decarbonization, including all sectors, and all the challenges faced by the island of Tenerife related to a non-interconnected island, basically, with a tertiarized, highly tertiarized economy, relying mostly on tourism, which has implications in the demand profile of electricity, and that also has implications in curtailment of wind farms in the island. But I mean, you will do it. I mean, you have a population is very sensitive to the fragile ecosystems of the island and the need for a fast. So I think that the Island Authority of Tenerife has an important asset on that population of the island, always wanting to do more. No? And well, you told us it's also something recurrent in the rest of the island, the high penetration of private cars. You mentioned 845 vehicles per 1,000 inhabitants in Tenerife, but that might be like the average in all 7 islands. No, we are very dependent on the private car, and I think we have to change that sort of mobility more towards public transport. And well, the only thing I would like to mention, because Pedro was telling us about the prices of competing prices between electricity for the electric vehicle recharging and possible hydrogen cost for the refueling of hydrogen vehicles. But I don't agree with those 17 euro per kilogram, Pedro, to be totally honest, okay? Because, I mean, you have, when you produce hydrogen, you have important marginal cost, the variable cost, which in Tenerife, at least in the southeast, you have excellent resources, both solar with 1,700, 1,800 hours, 1,800 hours of PV energy per kilowatt peak, and then wind with sites of more than 4,000 hours. So, I mean, with that resource, you're able to produce at 4 euro cents the kilowatt hour, and when you come to 55 kilowatt hour per kilogram of hydrogen, the marginal cost is less than 2.5, and then you have the capex, that of course that's an important depreciation fixed cost, but this is something, I mean, we have to be aware. Today we need public support to give the private initiative incentive to invest on, because the capex, of course, at current price, but everything, I mean, we will advance in the reduction, the cost reduction curve eventually, like we have done also with PV and other technologies. No? So, I mean, our cost objective, at least as we see it, in this part of the islands where we have big and important resources, both of solar and wind, it's in the range of 7, 8, and that's covering the marginal cost and also part of the capex. No, I mean 17 euro per 100 kilograms. That means that 17 euro per kilogram of hydrogen. For us, it's too high.
I totally agree with you. It was the price that
you launched in the tender, right?
Nowadays, but nowadays in the island. But in the future, if we develop the infrastructure for refueling station of hydrogen and for production of hydrogen, the cost will go down dramatically. Right. Even what the 8 euros per 100 kilometers is the price that's going to establish. it's coming established in the mainland, for example. No?
Right.
So I totally agree with you.
Yeah, and also the
Okay.
cost of the vehicles. You are now talking
cost
about
of the
30K euro per an electric vehicle compared to 70 for a hydrogen vehicle, but eventually the price of the vehicles will also come down. But I mean, in this first phase, more than discussing whether it's private electric vehicle or hydrogen private car, hydrogen we're looking at for the buses and trucks. I mean, because you already have commercial technology that's covering the needs for electric vehicles. So, Pedro, thank you very much. Pleasure having you with us here. And okay.
Okay, thank you very much.
So yeah, we are running late on schedule, and we have the coffee break now. We were expected to come back at 11:30. I think we can come back at 11:45. And for the people that are on streaming, yesterday I think we had 230 something on streaming, and here physically we were about 90. Today, maybe, I don't know the numbers today, and on streaming, I don't know how many people are participating. No? But, okay, so we shall be back in 20 minutes, okay? So we have a quick coffee break, okay? So, good morning, especially for those that have just joined the streaming, the sessions on streaming. We will begin now with the second part of today's conference. Our next speaker is Simon Meyer. Am I pronouncing the last name correctly, Simon? Yeah, right? He's the head of the energy system, head of the energy system at German Aerospace Center, DLR. DLR, well, it's a very strong research institution, a European reference, world reference on aerospace technology, and also for technologies that are helping advancing the decarbonization and to more sustainable energy systems. Simon Meyer, he's a master's in chemical engineering from the Karlsruhe Institute of Technology. He's now currently engaged in several European, German national projects, and well, they are leading experts in Germany, advancing and very instrumental on advancing on alternative fuels and sustainable energy solutions. So, Simon, thank you, and a pleasure having you here, an honor, and please, the floor is yours. Okay?
No, yeah, perfect, thank you. Thank you, Salvador, thank you, Santiago, for having me here and for this great opportunity to talk at this conference. I guess the first thing I have to say is I'm not head of the department. Yeah, I'm a part of the department for energy system integration, but not the head. Yeah, the title was, given or at least like discussed within IGC and DLR, and I added a subtitle to it about especially the importance of transparent assessment methods. Why this is required, I'm gonna elaborate about that. So when I first had the title given or have discussed about it, I tried to find or get an idea of what is the actual energy requirement and energy system look like at Gran Canaria, and I found the slides from Pierre Navieja from 2022. It's a bit different from what we already saw from ITC previously, so obviously it has been updated, but nevertheless, I don't want to focus on the numbers. I just want to have like the view taken on these icons here, and basically the idea and the problem we are always standing in front is how to select which option about another, and what is the actual benefit of that. And that is something where we are working on, and basically, I mean, this is the problem then, right? So we have some options to have to reduce our carbon footprint. We have some certain amount of costs for that, so we can calculate how much does it cost for abating 1 ton of CO2, and in the end, it has also some kind of potential to reduce, and so therefore there could be a defossilization concept 1 or 2, and let's assess it and see what is the actual benefit of that. And then the EU provides also a concept of how to actually make such a option beneficial on the market, and this is about the CO2 certificates. So if we are able to somehow abate CO2 under a certain price, there's actually a business case. So to be able to actually address these and to assess these different options, we need a standardized methodology for the LCA and for the TEA. So, and this is what we are mostly working on in our research group. So if we have, once again, a look at these options, I highlighted where DLR is also doing research in, and this is quite a lot of them. I would say not really in the hydro pump storages, but in the energy storages, definitely. And in our department, we are mostly focusing on heavy duty transportation and also on aviation and trying to decarbonize that. So this brings me to our institute and to our Department of Energy System Integration. So our Institute of Engineering Thermodynamics is having like 200 employees. The whole DLR has around Germany 10,000 employees, and TT is quite a large institute within that complex. And within that, we are in the Department of Energy System Integration. And as you can see already on the images, so our focus is on some clean aviation concepts. In this case, this is a study for like 100% fuel cell based aviation. In the middle, you can see a concept study for SOFC, so solid oxide fuel cell systems on a ship. And then on the right side, you can see a pressurized electrolyzing system together with connected to our colleagues from combustion technologies with a gas turbine connected to it. And our major target is to develop fuel cell powertrains and integrated electrolyzer systems for sustainable fuels to reduce carbon intensity of hard-to-abate transport in general and aviation in particular. Our department looks like this, and there you can also see further pictures of our studies. So the actual head of the department is Asif Ansar, and we have the group which is looking into flight based on fuel cells. They are based in Hamburg. Then we have a huge facility now, which is called BALIS, where we are trying to investigate the hydrogen infrastructure which is required to actually establish flight with hydrogen, with liquid hydrogen. So therefore, this whole new technologies have to be tested. Otherwise, you don't get the license for aviation, and therefore these test facilities have been set up, and I think they had been inaugurated a few months back. Then we have also some group which is looking into low temperature electrolyzer system, and as I said, also the high temperature electrolyzers, always pressurized and not pressurized systems. And then we are here in the group of techno-economic and ecological assessment. And we are working very close with the other groups to be able to really address and to see the impact in changing something about the technology and the impact on the costs, but also on the ecological part. And therefore, this is going always hand in hand. And to give you an idea of what and how we are assessing these technologies, I'm going to have a few more slides about that. So the major focus is to have an assessment of these processes and these technologies to defossilize our energy system economically, technically, and ecologically, and looking then, of course, at efficiencies, carbon conversion, and specific feedstocks. We do also do, of course, an economic assessment and are able, in this case, to say which concept makes more sense within which boundary conditions. I'm going to give you an example later on. And the LCA part is also, of course, a major contributor to our work, since if we are having an economic business case, that's fine, but in the end, it has also to have an impact on the ecological point. We have a tool which helps us do that. So starting with an example for a technical assessment and how we can then contribute and support to evaluate what are valid options to decarbonize such an energy system. This is a PTL process conducted from a former colleague of mine. So we have a CO2 purification. In this case, it's from a cement plant, a reforming step, the Fischer-Tropsch synthesis unit in this case, and an upgrading. And in the conducted study, it's proton exchange membrane electrolyzer. So, and I'm going to go roughly through, but I just want to show how we are trying to really go into detail with the modeling, and then still keep the flexibility to really then see how do different boundary conditions actually have an impact on our process design selection. And in this case, as I said, we had a cement plant and an electrolyzer system modeled. We had a reforming step to activate our CO2 and to convert it to CO, which was required for our Fischer-Tropsch synthesis unit. And in the end, we had a recycling, and the recycling in this case was affected by the temperature and the pressure in our reforming step. And now the study or the results I wanted to show is basically how do these operating conditions of a single unit affect the whole process chain. So therefore, we had a look at the carbon efficiency of that process, and we were able to see that, okay, if we are changing the temperature, or lowering the temperature and increasing the pressure, it doesn't even have a high impact, but decreasing the temperature is obviously better for our carbon footprint. So carbon efficiency, sorry. The reason for that is that we had a higher recycle to the reformer step. Yeah. Next is having a look at the hydrogen efficiency, which might be the most important thing to look at if we keep in mind how expensive the hydrogen is. And in this case, we saw that actually increasing pressure is not at all what we should look at, because then we are losing much more of our hydrogen in the form of water formation. And due to the purging, we should actually go to lower operating pressures and medium temperatures. And then we had a look at efficiency, like the overall power to liquid efficiency, and we were then able to see, okay, something in between, like the average condition like 5 bar and temperature around 800 is the most beneficial operating condition. And like this process, we are assessing at the moment and more in towards the SOEC system, so the actual hydrogen production. I mean, and but in this case, it was the focus on the reformer. Also, there's a further study which then also showed that this is not only the technical optimum, but also the economic optimum. Another example, just roughly, was I just brought mostly examples because we had already like this high-level investigations a lot, and I thought it might be also interesting to see a bit more in the technical part. So therefore, this is an assessment of a biomass to liquid process where we had a gasification system, as you are also planning to have one here. And the problem always is, as we already heard, the disadvantage of having a carbon to hydrogen ratio, which is not suitable for the fuel actually, because biomass you always have like a carbon efficiency of around 30–40% maximum, and after that you actually even are emitting CO2. And therefore, it is always like a good idea to think of ways to not run it only on biomass, but also include the hydrogen. But nevertheless, so for this case, we had a purely biomass to liquid process. And we tried to identify sweet spots within, in this case, Central Europe, We had a refinery located in Litvinov with our project partner of Orlen Unipetrol. And this was a EU project together with VTT in Finland, who were the experts for the gasification. We had Wood PLC for actually looking and validating the costs which we were estimating, and also we had Ineratec for the Fischer-Tropsch unit in that case. And as we were able to see on basis of the potentials and the market on different regions, we were able to actually not only calculate the production costs, but also identify which process design is actually the most beneficial depending on the boundary conditions. And in this case, we had two cases where straw was actually chosen over bark. So bark is usually a residue out of the forestry agricultural procedures. And then, yeah, we also had like the most sweet spots were somewhere in Poland and in Hungary. Yeah. And then I come to the comparison of actual, like the integration of a power and biomass to liquid process. This was also conducted within an EU project, which was called FlexCHX. And in this case, we were not only integrating the electrolysis into the reformer, like with the hydrogen, but also the oxygen was used for the gasifier. And then we did the ecological analysis of these processes, and we had like a comparison of what's the actual global warming potential of these two. And as it can be seen, depending on the electricity footprint, we can see that PBTL, so integrating power into our process, usually always increases our footprint of the product. But nevertheless, we always have to keep in mind that we are basically able to double, even maybe 2.5 times having the product output than we would have if we are running with BTL. But nevertheless, if we are looking at like the only aspect of the footprint of our product, then all the time, except for like really green power production, BTL processes were more green, more renewable than the PBTL case. If we compare that with the RED II for fossil fuel and the limit for having actually the certificate that you're producing some renewable fuels, we can see that the BTL is even, of course, it's also consuming electricity. That's why it's also increasing, because we have some compression steps and we are having, of course, some losses there. But nevertheless, it's still able to be beneficial and to be a renewable fuel. For the PBTL case, we don't. It's not always the case. We then had a look at some grid mixes, and I just picked some because Sweden and Finland were our project partners. France is an example for quite a high developed country, but of course because of their nuclear power, they are having quite a clean power grid, or at least green. It's labeled, and then we have like the average in Europe. And Germany was quite far off, and I didn't include the flag of Gran Canaria. Yeah, it's somewhere. Yeah. All right. So we can conclude the RED II can be reached for all the biomass-based production routes. The PBTL requires electricity mix. Either, of course, you can connect it directly to your renewable electricity generation. That might be a deal, but of course, on the other side, we have to become green as a total island, right? And not only produce some fuels, and that the grid keeps being dirty. yeah, so therefore it has to be below a certain threshold, and then we have a PBTL case for Sweden. Yeah. Summarizing my talk is that the standardized methodology for techno-economic assessment and the life cycle assessment allows the in-depth analysis of single process steps and to actually identify site-specific process design selection. And then we are also able to really transparently compare different defossilization strategies and to really say, okay, choose this over another process. The other conclusions I think I've stated in the slide before already. And the outlook for us is definitely to extend the scope. I mean, I've just shown only Fischer-Tropsch units, to be honest, or and even the upgrading to biodiesel and SAF. But nevertheless, we are also conducting, of course, looking into methanol, looking into ammonia. We are at the moment in a project where we are looking into offshore production of PTX. So then the idea is to really have a platform to produce your fuels there. And there ammonia is quite a promising, I would say. And then also we are having a look into methanol-based jet fuel production. And then finally, also other feedstocks could be investigated. What I've shown was a biomass based on straw and bark, but of course also some municipal waste or even algae-based production routes could be investigated and should be assessed. And with the references, I thank you for your attention, and yeah.
Thank you very much, Simon Meyer from DLR Germany. Nice presentation, and it's interesting to see how the group at DLR is working on advancing on e-fuels, and how you are also looking at the efficiency part and how maybe biomass less efficient when you come to as a feedstock for your gasification process in order to get the syngas you need for the different Fischer-Tropsch or whatever. But if you take into account the footprint, of course, then it has to be biomass to liquid, definitely, to comply also with emission regulations, no? Affecting the, and yeah, it's okay that you're also looking at ammonia, among other things. I don't know, I mean, because there's now still the discussion whether ammonia, methanol, I think both will have applications, no? And some have methanol, some benefits over ammonia, of course, but ammonia also has also its benefit. The first one, we don't need carbon to produce it. We can get it only from the nitrogen. 79% of there is nitrogen, and from green hydrogen through renewables. No?
Yeah.
So I thank you very much, Simon, for coming, and yeah, thank you. Okay. You wanted to comment something else? No. Okay. Yeah, we will have the chance anyway at the end of the session to make questions to our speakers, no? And our next speaker, Ramón Castella, he comes from Carburos Metálicos. He's part of the Air Product group, well. Ramon, he's based in Barcelona, right, Ramon? Or you're still in Barcelona? Yeah, in Barcelona. He's an industrial engineer from the Polytechnical University of Catalonia with an MBA from the Tarragona University. Been at Carburos Metálicos since 1989, held in different positions throughout the year, the technical, mostly focusing on safety issues within the company. Currently, he's in the has a European role as traded chemical and acetylene technical manager, supporting the business across Europe for the safe management of several chemical products, including ammonia and hydrogen. He's member of the European Industrial Gas Association and also a member of BECINOR, the Spanish Association for Normalization of Industrial Safety. And well, he will be speaking today about the safety in operation of chemical industries, particularly related to hydrogen and ammonia. So, Ramon, welcome, and the floor is yours. Yeah, floor is yours.
Okay, thank you for your kind presentation, and nice to be here. I'm going to talk a bit more about the technical aspects of these let's say, processes, because at the end, we are talking a lot about the need for decarbonization and the need to do it properly. But at the end, this is a chemical process. This is a risk, and there's a risk in transport. This is a risk in everything. And the scale of this business will change dramatically in the coming years. Then, before the start, our company, it's Carburos Metálicos, is 125 years old. It's one of the 50 companies older in Spain. And we belong to Air Products Group that is 75 years old, based in the US. And the Air Products Group has 65 years experience in making hydrogen. And actually, currently we are the largest producer of hydrogen in the world, because until today, this is more or less from the gas companies. In the future, will be much more players in the manufacturing of hydrogen. We have now 30 projects around the world about electrolyzers. We produce 9,000 tons per day of hydrogen today across the world. We are 22,000 employees in the world. We sell ammonia. We are not producing ammonia today, but we will produce as well ammonia. Until now, we are only distributing and making distribution and refilling. And we are investing currently $15 billion in energy transition. I think yesterday the colleague from the US was mentioning a large investment in the US. We have large investments there, but also in Europe. Well, the overview of the presentation, we'll start with chemical plants and safety management, then particularly with ammonia, at the end with hydrogen, and focus in some risks, emergency scenarios to be considered when doing this business. As I said before, the processes of hydrogen, ammonia, and all the related with this business have risks. And by definition, as a process safety definition, we need to design and manage the installations to prevent any catastrophic failure, toxic release, flammable release, explosion, and we need to take into account to protect our people, the environment, and all property. Then all is managed by, at the end, in the chemical plants, we manage the risk in a general way with a kind of matrix, as you can see in the screen, where we try to put mitigation measures all across the supply chain of the production to be sure that we are in the green area, then that the frequency of happening events is as lowest as possible. This is a diagram that is for, we use in the company for process safety management, but process safety management is a well-known standard across the world, and is based in certain principles that I'm going to highlight a little bit later. Not all of them, and not in detail, because we do not have the time to do it, but at least to try to provide some overall or some general view of the management of the safety. All starts with the safe design. Now, you have seen in these 2 days that everyone is designing plants, gasification units, and all starts with, for example, the definition of the location. You will have soon in some ports, in some areas, some industrial areas, big storage, big things with some risks, and it's good to evaluate first which is the best location, the best layout, also between the facility, inside the facility, which is the distance with the buildings, the public occupation, schools. We cannot build a big storage in front of a hospital, for example, and this is also involving the government's planning for houses across the areas. Then you start designing the process, piping, instruments, whatever, and doing what we call a design hazard review, HAZOP, or other methods as well, and implement safeguards and more safeguards, and duplicating safeguards, evaluating if the instruments to be used are safe enough, reliable enough. Then equipment. We have been talking about high pressures, 350, 700. Then this is not the same as operating with water at 1 bar. We will operate at very high pressure. Then equipment needs to be very well certified and maintained. And then for operating the plants is needed a very accurate documentation in process safety. And this should be very strict and is the Bible for the survival of the plant, and to be sure that we have for the future all the proper spares, specifications, and design basis for the components. Once we build something, we decide where to build. We do the buildings, the process, the plant. We need to start up the plant. Startup, it's an important part of that, because if something wrong, we can be injured or we have big problems. Then for doing the trials, we need accurate protocols, engineering operations standards, and define how to do trials, how to operate as well, but first of all, how to do trials. For example, cleaning pipes that have been welded, for example, have metal parts to be cleaned, and ensure which is the training program that is required for the future operators. And once we have the plant built, we need to be sure that any change is in control. We cannot do uncontrolled changes. Any change should be approved, shall be approved by competent people, and we need to be sure we update the documentation. For example, if we add a new pipe and we are not evaluating the safety of this part, we may end up doing mistakes in pressure rating or whatever. And then we need to be maintained, need to do the proper maintenance program, and more than maintenance that we can say, okay, need to replace the oil, you need to do painting, whatever. No, the most important, all is important, but the part of mechanical integrity, it's very relevant, especially in aging and conditions. For example, here in Canary Islands, it's very nice weather, but we are here near the sea, we have more corrosion, we are in a windy area, we have sand, and we need to take sure different measures than in Finland or in another country. And then compliance with the regulation first, compliance with the procedures, auditing, ensuring that the plant is operated safely. And then managing the contractors, the work permits, the jobs that are being done inside the plant. with non-standard procedures and prepare the proper procedures for maintaining the plants safely. And also, we are never, zero is the aim and can be achieved, but nothing is sure that nothing happens. Then we need to plan properly emergency scenarios. I think later on there is a presentation about emergency plans for this type of installations later in another presentation. But needs to be considered to define the scenarios. For example, define if I have a leak, how big will be this leak, which will be the distance, how many people live in the area, and which is the mitigation measures, which are the mitigation measures that I need to take into account, and train all the people to react as soon as possible to any emergency. Then learning from incidents, obviously. Everything that happens should be reported. We need to learn about what's going on, not only from our incidents. Now this industry will be very big. Sure, because of statistics, something else will happen than now because the scale of the business will be much bigger. And we need to learn in the industry from everyone, and if necessary, apply retrofits. Then this was general and is valid for any chemical business, including ammonia, hydrogen, or all other chemical processes involved in this energy transition or not, or in other business. I'm putting some general properties going to ammonia. All is you can find in bibliography, but just to take into account some of them. Okay, it's toxic and corrosive. Corrosive also for the skin. It means that if this is a big leak and this is touching our face, our eyes, this is corrosive. This is harm. Then we shall avoid any leak. It's not highly flammable, but it's certainly a little bit flammable. Then when we design plants, we need to consider this risk, and we need to have proper instrumentation rated for flammables. Reacts with water, but at the same time is mixing with water. That means that if we have a release into the environment, we will contaminate the water. Then we can pollute rivers or everything. Materials of construction, compatibility, it's typically considered in engineering. And then just some of the properties that I wanted to show. Vapor pressure, it's about 8 bars at 20 degrees. Then probably in the ammonia tank that is here in these installations, in a day like today, if this is plenty of ammonia, will be around 10 bars as an order of magnitude when you have in pressure vessel. Boiling point, minus 33. Why is important that? Because the big installations that are going to be built in the ports or in the redistribution areas mainly will be cryogenic, will be liquid and atmospheric pressure. That means that you need to keep the ammonia at minus 33 to be at 0 and to be liquid, to have higher storage. Specific gravity, 0.58. Lighter than air. Lighter than air means that if we have a leak is going up. This is very relevant when you talk about chemicals. It's not the same going up and going down, because the clouds are different. The toxic clouds, I mean. And smell limit. Some products are not smelling. For example, carbon monoxide, you can be killed because it's not smelling. Ammonia is smelling. That's what it is. 5 ppms. Compare it with other chemicals, dangerous chemicals, as chlorine or fluorine, that are 1 ppm. But still is easily perceived by nose. You can find it at home with the ammonia cleaning solutions. But at 300 ppm, it's dangerous for life. if you are 30 minutes at 300 ppm, starts to be a problem. That this is important, the loss of containment. Avoid loss of containment. Well, this I saw yesterday some of the presentations about pressure vessels as well used, and I'm going to comment a lot on that because you saw yesterday, but typical storages for liquefied, atmospheric pressure, refrigerated tanks. Normally the big ones that will be from 2,000 tons or 3,000 tons in the new gasification areas, and the other one is a little bit similar than the one that you have here, for example. This style, but pressure vessels that need to be rated at 33 bar. About ammonia, this is some considerations in the design of ammonia installations. You need to consider which are your safe radius. When you have a leak, you need to consider which leak, which size, which time, duration, cloud, distance. With that, you know which is the effect that you may have in the population, in the distances, and emergency plans to consider. Loss of containment, you need to have bands that if something is lost, you need to contain. Neutralization systems, gas detection, also commented in some of the presentations before, high pressure in the tanks, equipment ATEX, emergency stop. Emergency stop far away from the area of influence because you need to stop any emergency not going there. And maintenance provision. We jump to hydrogen. Hydrogen, as you know, it's flammable, easily flammable, and you need to assume that any single leak of hydrogen can be ignited. Here, in a comparison with the other, for example, with propane or methane, hydrogen is igniting very low. For example, a typical spark that you can feel in static electricity, it's 1 to 10 millijoules, and hydrogen is 0.017. That means that it's easier to ignite than static electricity that you can feel, for example, in winter with dry days. Well, sources of supply, I think we have seen this couple of days also, some of them, liquid or gas, and the refueling stations. Also, we also have refueling stations, as commented. Several ones presenting also have installation, and you have one here in ITC, and we have one also in, yeah. Liquid hydrogen and gas hydrogen. This is they are the things that the ways to store products. I think we commented also in this couple of days. Liquid is basically in double wall vessels, and the cryogenic part is inside, and the other is a chamber to protect the inner vessel from the outer vessel and isolate, maintain the temperature. And the gas trailer also is pressure vessels. Imagine the packs you have seen here next to the fueling station, but much bigger and much more together. Refueling station, typical layout. I think after this couple of days also you have seen some of them. The same, what is there, but I think also you have seen here in front of that. That is a very good example. And then emergency scenarios, that's the last part of the presentation. Emergency, you can have nothing, just for example a rollover, and you may have to do a transfer to another tanker or to vent. As hydrogen has a non-visible flame, it's very important to be sure that you are not going there without protection. And for example, thermal imaging cameras are good ones to prevent or to identify if something is happening. You can have a fire. If you have a fire, it's what it is. What you need to do is to cool down, especially cool down what is around the fire. You cannot extinguish the flame, and you should not. And especially in liquid hydrogen, you never have to provide water into the liquid part because you are going to freeze and will be worse. Then a lot of water to cool down. The flames, as commented before, you have in the middle a hydrogen flame, but in the night, but in the day, I can tell you that nothing is visible compared with another flames. Then you need to approach properly with, if you can, with thermal imaging cameras or some way to approach safely. I put here some reference documents. I think in the presentation you can read much more about that and expand your literature. Some of them are quite new because hydrogen, for example, in March, it was published a guide in Spain. Gas industry is providing much more as well. And this is a challenge because the scale of the business will be much higher in the future. More legislation will come and more technical documents will appear. For example, now in Spain, the ammonia storage regulation is being already studied to be modified. And that's all. Just here, a picture from Barcelona America's Cup where we are the suppliers of hydrogen for this event, and hopefully we'll be safe managing these businesses. Thank you.
Thank you very much, Ramon Castella from Carburos Metálicos, our product group. Always, we have to be very thankful for the support we're receiving for Carburos. I mean, we have installed so far 5 electrolyzers through public tenders, and always Carburos has managed to, in the bid to get, and the support has been, I mean, we have not, and Ramon from Barcelona, and the team here of Carlos, excellent attitude, not only expertise and know-how, but especially the attitude, the proactivity, always there, and the willingness to help. And in the case of Ramon, we learn a lot from all his advices because, I mean, like everything in life, risk-free, totally free. I mean, when you take the bus now to the airport or to the hotel and the plane back to Seville, for now, I mean, there's always a risk, but if we do things correctly, we can mitigate the probability, reduce probability. But as Ramon was saying, mitigating risk means beginning from the design to consider all elements, and then all the incidents, monitor them well. And then, not only your internal, but also all the subcontracting you are doing, you have to monitor well what they are doing as well. So it's tough, but you can do it, no, Ramon? Mitigate in your experience, reducing risk is possible.
The objective is always zero. It's difficult to achieve, and with the large-scale projects that are coming now, will be more difficult, but technology needs to improve, but it's a way of management. This can be managed, it shall be managed, for sure.
So thank you, Ramon. Thank you for the team, Carlos' team. Angelica, Ivan, he's not here, but he's one of the people that we thanks to them, we have been able to finish the biorefinery. And this biorefinery also, because Ramon, he has come to talk about the hydrogen and ammonia. Ammonia was our first choice because of the feedstock. We had nitrogen there and hydrogen, but as part of this biorefinery, we also have a smaller biodiesel plant. So from used cooking oil, we produce our biodiesel, and then as a byproduct, we get glycerin. Today, we're paying for someone to take it and dispose the waste. But the idea, as Dr. Celia Bueno explained yesterday, we have also included a gasifier for that waste in order to get a syngas with carbon monoxide that can be used to synthesize in the future also organic e-fuels. We beginning with methane, methanol, of course. Eventually, for our friend Francisco, for his planes, synthetic kerosene. No? That would be the. So I mean, this is something that we would like to promote and with the local universities, both the Universidad de Laguna in Tenerife and the one in Gran Canaria, Universidad de Las Palmas de Gran Canaria. I think we will manage to make it, get to those organic fuels also. Okay. So Ramon, thank you very much, and we appreciate that you have come to Gran Canaria to be with us.
Pleasure. Thanks.
Okay. Bye. So now our next speaker, Tatiana Gomez. She's from the Island Authority of Gran Canaria, from the Energy Council of Gran Canaria. And Tatiana, well, she's an industrial engineer. She's specializing in energy planning at a very local level with the 21 municipalities of the island, working on the SECAPs, on the Sustainable Energy, Climate and Action Plans, and trying to coordinate this work, which is important. Always think globally, but you have to act locally. And acting locally means working with the municipalities, because a lot of things, I mean, from promoting renewables like PV, solar thermal, if you have the municipalities supporting, it's easier. Also, electromobility, it's also easier if you also have their support. So it's important to work closely with the municipalities. And well, Tatiana is also doing work now, research looking at agrovoltaics and looking for solutions to agriculture. And talking about agriculture, I mean, we are now in ammonia. Of course, our business is energy. We work on energy, and we want energy carriers such as ammonia. But ammonia, don't forget that ammonia is also the precursor for a very important industrial process that will allow us to get nitrogen fertilizers, like nitrato de ammonia nitrate, or the biggest nitrogenic fertilizer, urea. No? So having the possibilities of producing locally ammonia also brings, although it's not our line because we're only concerned today on energy carriers, but I mean for food sovereignty, and also part of Tatiana's work with the agrivoltaics, looking for also ways to implement more competitiveness in agricultural production in the island. Also, it's important that we can produce from wind and solar in the future fertilizers here. So Tatiana, please, the floor is yours.
Ok. Empiezo. Good morning, good afternoon, ladies and gentlemen. Thank you so much for the invitation to this event. My name is Tatiana Gomez, and I'm the coordinator of the Community Transformation and Energy Transition Office of Consejo Insular de la Energía de Gran Canaria. Today I'm going to talk a little bit about the definition and development of green hydrogen, some information about mobility in Gran Canaria. I will explain the most important parts of the project in which Cabildo de Gran Canaria through Consejo Insular de la Energía is working on right now, green hydrogen generation in environmental complex Ecoparque Gran Canaria Sur, and some conclusions of the project. First of all, I want to introduce what is the Community Transformation and Energy Transition Office. We was created to boost the initiative promoted by Cabildo de Gran Canaria through Consejo Insular de la Energía in the field of the renewable energy adaptation to climate change and energy efficiency. We have also promoted and advised 2 industrial energy communities and 3 citizens energy communities. We are also the coordinator of the Covenant of Mayors in Gran Canaria. So, as all we know, green hydrogen is the key sustainable solution for achieving the energy transition by 2050. It's also the most abundant chemical element in nature, and it has been used to fuel airships, cars, and spaceships since the beginning of 19th century. Green hydrogen is generated by a chemical process known as electrolysis. This method uses electricity from renewable resources, that's why its name is green or renewable hydrogen, in order to separate water molecule into hydrogen and oxygen. As all types of technologies, green hydrogen has some advantages and disadvantages. In the advantages part, we have that it's 100% sustainable because it does not generate any greenhouse emission during its combustion or production. It is also versatile and really very easy to store. And the disadvantage is the production of hydrogen in particular, and especially in green hydrogen, it requires a huge amount of energy. So it also has a high cost because all the technical elements which takes part in the production of green hydrogen are really expensive. And it also has some safety issues because hydrogen is really flammable. It's a really flammable element, and it requires an exhaustive safety issues in order to prevent some explosions or leakage. Here we have some information about the development of green hydrogen in Europe. We have the European Hydrogen Strategy, in which document explains that hydrogen will be developed in 3 different stages. In the stage 1, by the end of 2024, it is estimated that have at least 6 gigawatts power of electrolysis installed, and at stage 3, by the end of 2050, it is supposed to be that green hydrogen development will take place on a large scale. We have also the Spanish hydrogen roadmap, in which it wants to promote the installation of green hydrogen production and its application to transport sector. And in the Green Hydrogen Canary Strategy, this document has 7 specific actions talking about hydrogen. And some of the most important ones is the use of green hydrogen as a main alternative fuel for heavy load vehicles, and also as an element for renewable supply. Here we have some information about mobility in Gran Canaria. As we can see, the results of the energy diagnosis of Gran Canaria, the transport sector is the sector which more greenhouse emissions emitted by 2020. Especially the road transport, it was the emissions was 57% of the emissions. I wanted also to highlight the evolution of electric vehicles in the island. We went from less than 100 vehicles by 2011 to more than 3,000 vehicles in 2022. It is important because it shows how the mobility in Gran Canaria is changing in a really right way. So I'm going to explain a little bit the most important parts of this project. As I said before, this is the project in which Cabildo de Gran Canaria is working on through Consejo Insular de la Energía, and is the green hydrogen generation in Ecoparque Gran Canaria Sur. We have in Gran Canaria 2 environmental complexes. They are located, one in the San Bartolomé Tirajana municipality. Here in the image you can see where it is located, and the Ecoparque Gran Canaria Norte is located near to Las Palmas de Gran Canaria. They are separated a distance of 40 kilometers approximately. The main targets of this project is the green hydrogen generation in order to fill up 6 garbage trucks. It will be powered by photovoltaic energy. Also, it seeks to establish new standards in the production of green hydrogen and its integration into sustainable mobility, and to maximize the environmental sustainability. Some of the expected impacts of this project are in the socioeconomic area, for example, facilitating the incorporation of hydrogen-powered vehicles, also the technological development of this kind of technology in Gran Canaria, and the reduction of greenhouse gases emissions. Some of the partners of the project are Consejo Insular de la Energía as a coordinator, And the start date of the plant, of the hydrogen plant, is expected to be in April 2026. It has a total budget of 21 million euros, and Consejo Insular de la Energía has submitted to the Next Generation Funds through IDAE in order to implement this project. So here we have the current situation of the garbage trucks. The fleet, the current garbage trucks fleet is about 110 trucks. They are distributed in between 8 of the 21 municipalities of Gran Canaria. These kind of trucks are powered by gas oil, so its consumption is near 35,000 liters per year, and they also has an emissions of 96 tons of CO2 per year. The required technical elements in order to substitute the 6 of the actual garbage trucks, the future trucks must have an average truck load of 9 tons waste disposal. Also, they must cover nearly 10,000 trips per year, and also they must only take 2.5 hours per trip, in 50-minute time travel from one environmental complex to the other, and 50 minutes to loading and unloading waste disposal. Here we have the operation scheme of the green hydrogen generation. I will explain some of the most important parts of this. As I said before, the electricity supply will take place by a photovoltaic power. This plant will have a generation power of near 2 megawatts power. It will be placed over the roof of industrial warehouse. Here you can see in the photo some of the warehouses that are in the Ecoparque Gran Canaria Sur, and there where will be installed these photovoltaics in the photovoltaic plant. The solar surface will be near that 9,000 square meter, and they will have a performance ratio of 20%. The hydrogen generation will take place with a PIM electrolyzer. This electrolyzer is one of the most popular to use because it generates a really clean hydrogen and it's really easy to cool. This is the heart of the hydrogen generation, and the electrolyzer will have a power of near 2 megawatts. When the PIM is fed up with electricity and water, the electrolysis process starts. So we have in one part hydrogen, which will be transferred to the compressed hydrogen tanks, and oxygen that will be reused in the wastewater treatment, which is in the Ecoparque Gran Canaria Sur. Here we have some of the technical information of the compressed hydrogen tanks. This is really an important part also of the installation. It will be capable to give 300 bars of the hydrogen production, and it will have also compressed near 220 kilograms of hydrogen. Finally, we have the truck refueling. As I said, the objective is substitute 6 garbage trucks. They will have a maximum truck weight of 14 tons with a refuel time between 7 and 20 minutes. And it's important that they cover a range of 300 kilometers. The acquisition cost is estimated by 1 million to 1,100 million, 100 euros more or less. And well, this is really important because they will help to reduce the CO2 emissions that we have at the moment with the current fleet. And finally, I want to show some of the expected results. It is expected to generate near that 120 kilograms per day of hydrogen. The water needs of the plant will be at 787,000 liters per year. The photovoltaic generation is estimated by 3 gigawatts hour per year. And the consumption of the 6 garbage truck is estimated by 19% of the hydrogen annual production. They will help to the reduction of 86 tons of CO2 emissions. It's important to highlight that the support of public institutions to this kind of project is really important in order to help to the development of this kind of technology. Hydrogen will be the next, or is the future energy vector, and it will help to have a more decarbonized and flexible energy system here in Canary Island, and especially in Europe, or in Spain and in Europe also. Thank you so much for your attention.
Representing the Island Authority of Gran Canaria and the Energy Council of the island, Gran Canaria. Tatiana. Sorry, yeah, sorry. Yeah, well, I was just commenting the presentation that Tatiana just made us, showing what the plans they have for the landfill located in the southeast of Gran Canaria, at Juan Grande, where they have possibilities of disposing of wind, of PV, and the idea so far, you didn't mention it, Tatiana, but I think was supposed to work off-grid, no? The electrolyzer, is it grid connected? It's totally isolated, standalone operation, I think, no? I don't remember well. I remember talking to the...
Yeah, no, I didn't mention this part. Yeah, it will, the electrolyzer will work in a isolated way. This is the first draft of the project. Then we are working on implementing better improvements to this.
Okay, so yeah, they estimate 110 trucks currently being used for waste, for garbage collection, and the project that you mentioned is 120 kilograms a day, and it should give enough fuel for substituting 6 trucks in the first phase. No, so I think it's a very interesting demonstration activity you are planning to carry out, and yeah, we will be looking forward to seeing those 6 trucks soon in the island. So thank you, Tatiana, for your presentation, and well, it's that you can see that both island authorities, Tenerife and Gran Canaria, they are also promoting this integration of renewables and hydrogen technologies in the islands, and we have now to go to the other 5 islands also to get them on board and also promote initiatives, okay? So listen, I was informed that the last speaker is not, yeah, thank you, Tatiana. The last, that our last speaker, I don't know, he had some problem and he will not be participating. So, I mean, the conference, this was then the last presentation. If you have any questions for the speakers, please feel free to, yes, Robert?
Oops, now it's working. Just curious, Lincoln Hexagon is now Lincoln something else after some buyouts. Are big on composites, I guess carbon fiber. Instead of the really heavy steel, have you got as Air Products considering that for Europe? I think it's the deployment is mainly in the US so far. Sorry.
Yeah. Yes, as every time higher and higher pressures are required, now most of the installations are running at 300, 350, but 700 is already available and prepared. It's kind of fiber materials, and more studies are being done for 1,000 or something like that. I know that For example, aerospace industry is doing tests with very high pressures, and as mentioned yesterday, the materials studies and improvement technology, it's a clue on that. But yes, it's something is available already and something being developed.
Thank you, Ramon. Any other questions for the speakers? Yeah.
Maybe as complementary, and I have later a question for you also, Ramon. Yes, we are in there. I tried to briefly comment yesterday. Weight is there, in very basics, for the same level of pressure, a CFRP tank or distribution system could save no less than 25–30% on the weight of the system, which is key for us. And we are investigating that area. Even the basics tanks with no liner, pure CFRP, high pressure vessels are under investigation on our area. Ramon, for you, I was interested on your safety approach analysis. Again, translating to the aircraft, we are flying there with hydrogen, with the cryogenic system, with the fuel cells, with the thermal management for the fuel cell. Everything is there flying at the same time that we will move from here to the destiny. So, do you have, what is in your view the basics of the most risky scenarios, very high level, because we are exploring with the regulations, with the regulatory authorities. We are exploring kind of 3 levels: low risky hydrogen leakage. I mean, it's there and it evaporates, so will be somewhere. Medium risk, meaning you can have kind of fire or kind of more risky leakage scenarios, and the so-called explosion, which is for us is a kind of no-go. Okay, and in the current studies, we are, I repeat, as yesterday, we are in parallel discussing that with the regulations. It seems to be that the typical fire is unlikely. Either you have a leakage, low risky leakage, or you have an explosive scenario. What's your experience about that?
Yes, well, I'm more in the storage and supply chain of these products, but the approach I think is the same from safety point of view. That starts with what you are doing. You mentioned it, the design has a review and considering all the scenarios. And if something is no go, you cannot go, that's for sure. For example, in the aerospace industry, we are supplying as well oxygen for the oxygen masks that are used in the planes, and we have a lot of restrictions in quality, purity, quality controls, and I imagine this will be the same in the case that we supply hydrogen, but much more because the danger is still higher, but it's part of the design hazard review and these scenarios. It's a scenario that is new. You have for sure risk with kerosene today that are evaluated, and with the hydrogen I think will be similar. But I'm not expert in this planes design, but the approach I think is the same.
Thank you, Ramon. Listen, we have been informed that the final speaker finally made it to our installations, and his name is José Antonio Amador. He's the CEO of the security company that's providing us the service, for the security plan of our installations. So we wanted José Antonio just to give us an overview of the security, all security issues that have been identified, analyzed in the small BIOGREENFINERY we have installed. And please, José Antonio, yeah, please come with us. Yes.
Okay, I see that security boy, security guy, broke the car. It's a thing that is not possible to control, but today was a bad day and my car broke. Okay, in security, for us, the vision of the BioGreen project was about different areas, because we must have a very extended legal regulations that was about more different points, more different aspects of the work in the BioGreen plant. First, we have the Real Decreto. You have there those basic norm of auto protection, and there is a lot of regulation for construction, for the work, for the area, for the biodiversity, etc. We have a lot for you. If you want to see, you can see there is some of the regulation. This is some of the regulation that we have. Principally, the technical code of the edification, and there was a lot of for incendies and other things. And we have, is more of that, you see, and a lot. Because we have regulation for the country. We have regulation at the level of all the country, but we have regulation in the community. This area, Canary Island, have regulation specifically for this type of work. But we have regulation too in the we have regulation in local administration here, or another regulation that was we must have a complex to put all the regulation in order to was possible to work. In Spain, we have the National Security Department that makes some guidelines in order to work. These guidelines, that was normally in different inform, was explained in the Security National Plan, in the Strategic Security National Plan, and have a lot of areas. And one of these was security, natural airspace, crime, and have terrorism, maritime security, and security energetic national. We have a strategy specific for national energetic areas. Okay, bueno. We have, at the same time, to have a protection for the level of anti-terrorist attacks. We must have fences, TV circuits, and other systems that was needed for the security, for the area, for the physical security. We have to maintain the physical security, the cybernetic security in all the areas, informatics and other areas, but at the same time, Plateca and other plans, we have to maintain security in the possibility of, you say a few times ago, the security, it was possible, earthquake, meteorological adverse phenomena, seismic, and other things or possibilities that was possible to affect not only to the plant, but the plant and the area that was around the plant. We have to have different types of maps. In these maps, in order to see at what areas was possible to affect for a person, for the people that was living here, near here, for the plants, specific wildlife that was here, that was protected, for the possibility for have other areas near that was possible to have another type of or affectation, Here, okay, this is possible. This is the plant. But near the plant, you see, this is the area with the river run to the sea. Then this area is very near to areas that was protected of different types of animals, to vegetals, and other things. And at the same time, there is near, in this other area, people that was living near the plant. This is the different problems. Then, we must have different studies for the surface in order to see how the water, how the different situation was possible to prevent the overflow, was possible to prevent the different phenomena that was not normally no success. That was phenomena that success sometimes, but in this time it's possible to have a big damage for the people that was near or for the area. At the same time, we must have a vision of what resources are near for the plant, at what time, not at what time in 1 hour, at what time in different hours, at what time in different days that was no laboral, days that was laboral, at the hour that the people go to work, and then we must have different studies for determining the times that the resources is possible that come here for fire, for police, and for other things. And the possibility for take people that was damaged in the plant and go to a medical center or a sanitary center. This is the studies and times. Have different, not only see the more fast possibility. We look for different types. Normally 2 or 3 possibilities for different roads that don't was the same in order to see if the road have a problem, it's a car, a crash, another thing, was possible to make the other and was possible to have a possibility for no stop the helps. As you see, this is how you say that the fences and other areas that delimitate the biogreen plant, but it's inside the ETC. It's inside the ETC, and then it's an area inside. Then one of the first points that we put in the plan of security is that the biogreen plant need have a special protection different and fence that difference the work in this area, the work in other areas, because each area have different damage, different risks. The risk of the areas was different because the activity is different. If you work, for example, with another type or activity for investigation, then the risk is different that they work in this area. Then we need to determine what areas was for each time. In Plateca, in Gran Canaria, we have a territorial plan for civil protection. This plan is a plan that have different vulnerabilities, different possibilities for the risk. We study the total risks, the social risks, the economic risks, the vulnerability, the social exposition for the calamities, and other risks. But not only this, but a lot more. This is the dynamic of the movement of the ground. Possibility for cut down of the electricity. Possibility for have different types of for temperature. Temperature is an element that is important because that the production is not the same. It was cold or was very hot, the weather. Then we have different scenarios. This is for economic exposition. This is for vegetation. And normally, this plan, this auto protection plan, is very extended. have 600 pages. 600 pages of evaluating all the risks, evaluating all the possibilities, evaluating all the things that was possible there in the plant. Sorry for my English. Sorry for my English because I have a very bad day. I must take a ship to come here, take a plane, the car, crash the car. Well, so I don't have my...
So
it was a little responsibility for coming here for you that I know that I was waiting for this and I was coming for this. Sorry.
José Antonio, thank you very much for the effort of being with us. And well, you gave us an example of possible risk, sometimes difficult to identify, but things happen. No? You have the probability that the car will not stop when you more need the car. No?
If someone have some question that I could answer, you have some question?
Yeah.
Well,
I just wanted to comment, José Antonio, on your presentation. You are especially concerned about the need for correctly identify the risk factors, and this is something very critical, and also foresee all possible scenarios that might be affecting those identified risk elements. No? And how important it is to have a rigorous analysis, evaluation, and it's seen in a 600-page report for the evaluation of risk of our BIOGREENFINERY. No?
Not only physical, but physical and other types of risk, because it's very wide. The possibility of risk is very, very wide. Then it's very difficult to take and say, I have a plan that have all the risks in the plan. Impossible. If someone says you that he sees all the risks in the plan, really, like, because it's very difficult. It's impossible to have. We have a 90%, 99%, 95%, but in each plan is a 5%. That is impossible to have a solution. Mm-hmm. It's impossible. If some asteroid come here and take we can make nothing.
Okay. So, José Antonio, thank you very much, but we are running late on the scheduled time for finishing our conference. And again, we appreciate the effort you have made to overcome this risk factor. Yes, come here and be with us and give us the information on all this rigorous study you have been carrying out at the facilities. So, José Antonio, I don't think we have more time for questions because we have also people on streaming waiting for. So we can close. Maybe Santiago, final words that you would like to give on the project.
Thank you.
First of all, thank you very much for all the people to come to these meetings. I think that at the end, BIOGREENFINERY project could be a really important project, as we mentioned yesterday. Now is the time to work. I mean, we have the research platform. The platform should work in real life. We have installed in all this period. Now it's time to test the facilities to see how this solution could be implemented in real life with real applications, and also to test solutions. And of course, all the people that are here from different companies have experience in different kind of solutions. ITC is always here for whatever you need, okay? Thank you very much for all.
So we close then the conference, and yeah, thank you very much. Okay.